permutations of a multiset. So what do you do when you need to count the number of rearrangements of a word where it has letters that are repeated? For example, the word sushi. It has two S's, so our previous result that says, well, if you have 5 different letters in a word and you want to count the number of ways to rearrange them, well, it's 5 factorial. Well, the only difference is that you have to take into consideration what happens if you have two things that are the same. And in order to think about this, let's label them with a 1 and a 2 subscript and make them distinct letters. Right, so S1, U, S2, H, and I. And now our old result, right, that says it's 5 factorial, does actually hold here. There are 5 factorial rearrangements. However, note that within these 5 factorial rearrangements, we count S1, U, S2, H, I, and S2, U, S1, H, I. We consider them as 2 different rearrangements of the same word. And that's not what we want here, right? Because really these just represent the same word, S-U, S-H-I, sushi. And so we notice that in order to get the correct number, where the S's are unlabeled and they're treated as the same object, well, we just have to divide 5 factorial by 2. Because for any way of arranging these letters, so I can write them like this, for example, with the S in front and at the back, well, there are 2 arrangements that are labeled corresponding to whether you put S1 first or S2. Okay? And we can extend this idea to, say, this word, which has more than one of its letters repeated, the B's and the I's, right? So this is the word bibimbap, which is Korean for mixed rice. So if you haven't tried bibimbap, I highly recommend it. It's really good. Now, I can label the B's, and I can label the I's. Oops, did I skip an I there? I skipped an I. Bim, bap. Right, so by labeling the B's and the I's, I'm able to form a word here that now has distinct letters. And so, using our, again, previous result in permutations, we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 factorial rearrangements of this word where all the letters B and I are labeled. Correspondingly, when we remove the labels, right? So when we remove the labels for the 2 I's, for example, well, that corresponds to dividing 8 factorial by 2. Because for any arrangement of the 2 I's, there are 2 possibilities. Either I1 is first or I2 is first. But now similarly, look at the B's. If we remove the labels from the B's, well, we're not just dividing by 3 there, right? But we're dividing by 3 factorial. And that's because there are 3 factorial ways of rearranging these 3 objects. 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Right. And so the correct number here is the number of rearrangements of the word bibimbap is equal to 8 factorial over 2 times 3 factorial. Where if you generalize this, well, actually we can put a factorial notation beside 2, right? Because really that's what it stands for, right? by labeling and then removing the labels of the i's, you're essentially saying there are 2 factorial ways in which we're overcounting how many arrangements we're actually counting, where the I1 and the I2 place doesn't really matter. And, well, just to generalize this, when k of the letters are the same letter, you basically just have to divide by an overcounting factor of k factorial. And so now we have the formula for what we call permutations of a multiset. And multiset here just means it's a set where we allow elements to be repeated. Right? So typically, if you have a set A, B, and C, when you list the elements in the set, you can't really list the elements in a repeated manner. But in a multiset, the set A, B is counted as a different set than, say, the set A, B, B, B. And so this formula says you just have to count how many objects you're rearranging and then how many duplicates you have for each type. So if you have n1 of type 1, n2 of type 2, and so on, then you're dividing by n1 factorial, n2 factorial, all the way to nk factorial. And that's it. So that's the formula for permutations of a multiset. So just to give you another example, how about the word, let's take a word from here, the word arrangements. How many rearrangements are there of the word arrangements? Well, first you determine what n is. How many letters are in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what letters are repeated? So first A is repeated and it has 2 copies. So that's our n1. Letter R is repeated, also has 2. Let's see, is n repeated? Yes. And there are 2 of those as well. And finally, E is repeated. So the number of rearrangements of the word arrangements, let me write this down a bit more clearly here, is exactly equal to 12 factorial over 2 factorial, 2 factorial, 2 factorial, 2 factorial, right? Based on the numbers that we see here.